from section 1.2 for the homework. So we went through this one in class as well, but I figured we didn't do the last part that asked about the number of successes. So I figured I'd do a quick video for you. So we have here that a candidate claims, here's our claim, that she has 60% support from the general electorate. Okay, so the claim goes with the population. Populations have parameters. All right. Then it says, so a random sample of 40 likely voters is taken. 21 of the 40 say they support the candidate, which is 53%. So when we take a sample, that one's obvious. That goes with sample, and samples have statistics, okay? So let's see, what are we sampling? Well, it just said that we sampled 40 likely voters. So we're going to have, or we're going to observe the likely voters, and then we're going to ask them, do you support the candidate, yes or no? All right, so that would be, then we would say, okay, person one, likely voter, two, three, all the way down till we collect 40, or we observe 40 likely voters. We're going to then collect, do they support the candidate, yes or no? That's what we're going to write here. This is my data, okay? My variable is, do they support the candidate, yes or no? And these are my observational units, each of the 40 likely voters. Okay, so let's fill in more information. So we know that the sample is n equals 40. That's my sample size. We're sampling a random sample of likely voters. They told us that 21 of them, of the them is the 40, 21 of the 40 support the candidate. That's 53%, okay? Because we wrote a category here, okay, this is categorical data. That means I have a p hat, or a proportion of success. P hat is the number of successes divided by the sample size n. In this case, 21 of the 40 support the candidate, 53%. All right, let's go back and talk about the population then. The sample is some of the things, or a subset of all the things. So we sampled 40 likely voters. The population is all the likely voters, all the things. Okay, the parameter that we're interested in then would be the proportion of all the voters, okay, not of the 40, all the voters that support the candidate. Well, we made a claim about what that was. We claimed that 60% supported them, okay? So pi is the parameter because it's a proportion. We really, even though we made a claim, it's really unknown, but we made a claim that pi is equal to 0.60 or 60%. All right, so we want to test this claim. That's the whole reason why we create a sample, a distribution of sample statistics. So to conduct that analysis, we're going to use an applet, okay? And we can use that to test if the claim of 60% support is plausible or believable. So we generate this dot plot, or this distribution of sample statistics, all right? So there's 100 dots in this simulation, okay? What does each dot represent? Well, we make certain assumptions. The first thing we assume is that this is true, that the claim is true. That way we can generate what would it look like if it was true, okay? We can generate what this sample distribution would look like assuming this is true, okay? And when we do that then, and we repeated it 100 times, so each dot represents a p hat, which is the number of likely voters, divided by 40. Each dot we want to have the same number, or the same sample size as our actual observation. We repeat that 100 times, assuming that pi equals 0.60, okay? So each one of these dots represents the number of likely voters out of a sample size of 40, assuming that pi equals 0.6, and we repeat it 100 times, okay? So then if we switch to, so now we have created a distribution that's approaching a normal distribution. It is centered at, or it approaches pi equals 0.6 because we told it to. We made this assumption. We told it to. And then we repeated it 100 times and we get this distribution. So it looks pretty normal, okay? About half the data is above 0.6, about half data is below 0.6, okay? But if we switch to, rather than the proportion of success, which is 0.6, if we switch to the number of success, what would this be? What would this center point be versus 0.6? Well, we know that p hat represents the number of successes divided by the sample size, okay? So if the center value is 0.6, we're essentially saying, well, let's let p hat equal 0.6 because that's at the center. All these dots in the center are at a p hat that equals 0.6. So if we say 0.6 equals the number of success divided by 40, then we just do algebra and we solve for the number of successes. We're going to multiply both sides by 40. So we get 40, that's our n, times what that center value is, 0.6 or pi, okay? And we do that multiplication, 40 times 0.6 is equal to 24. And that's it.